Okay, welcome back, physics fans. Here's question number 13 on page 8. Let's just run through this one. It's for the Physics 11 projectile package that you can download from the Moodle. Please make sure you're getting access to the Moodle where you can get links to all these videos and know which order to watch them in for your help and what's been assigned. A rock is thrown horizontally from a cliff at 25 meters per second. What will its horizontal and vertical velocities be after 2 seconds? This is surprisingly easy. The horizontal doesn't change, so that is still going to be 25 meters per second. So the horizontal will be 25 meters per second. And of course, that'll be horizontally. And vertical, well, it's just as if you dropped a rock. And what is its speed after 2 seconds? Because it's fired horizontally, that means it's dropped. It's not thrown down or thrown up. So the initial speed is 0. The 9.8 meters per second squared down, and the time of 2 seconds. So VF is equal to VI plus AT. That's 0. So that's going to be 2 times 9.8. Actually, 9.8 times 2. Same thing. It'll be 19.6 meters per second down. What will its velocity be after 2 seconds? It doesn't say horizontal or vertical. It just says velocity. So when it says that, give me the total velocity, which is a magnitude and a direction. So this is what we kind of learned on question 12. Let's practice it here. This is 25, and this is 19.6. So we'll Pythagorize it. I love that term, Pythagorize. I don't know if you could go online and not be criticized for using that, but I'm going to. So we'll take the square root of 25 squared plus 19.6 squared and square root it. So the total velocity is going to equal the square root of 25 squared plus 19.6 squared. So that is going to be 31.77 meters per second. And now I need the direction. Oops, don't want that line all the way down there. So the direction is given by the tan. The inverse tan of the y, 19.6 over the x, 25. So notice I drew the horizontal first, then the vertical, so then I can comfortably do this. That's the opposite over the hypotenuse all the time. And that theta is 38.10. So I'll put that down here, square brackets, 38.10 degrees, and then I have to write down BTH, below the horizontal. And there's my answer. Whoops. Okay. And then it says C will be after 3 seconds. So I have to find out the velocity after 3 seconds and then do all this stuff again. So VF is going to equal VI plus AT, which is 9.8 times 3, which is 29.4. So it's 25 and 29.4. So this is what we want. So V is going to equal the square root of 25 squared plus 29.4 squared. And then angle will be the inverse tan of the 29.4 divided by the 25. Okay, so let's do them together here. The square root of 25 squared plus 29.4 squared, and then the inverse tan of 29.4 divided by the 25. There we go. So our vector velocity, not the horizontal, not the vertical, but the total, so the vector, is going to be 38.59 meters per second. And the angle is 49.62 degrees BTH. Any questions? Thanks for joining me. Move on to question 13. No, that was 13. How about doing 14? And the preview of that, same thing, just a little bit different on calculations. Good luck.